I did something wrong. So I put comments here. I can say this part will help us find roots of functions. So part one will be by bisection method. So as Susan said in the morning, I'm just putting this so that I recall what I'm doing at each part. And when you have the script before you run it, you have to save it. By save, you can just go here and control save as or control S in your laptop. And then I can just call this any name, calculate root of a function, just F, just any name you want, provided you can recall it. And also it's not something which is stored in MATLAB. And so I've saved this. And when I start, this is just housekeeping. Let me leave them. So what I did here, like at this part, I can also do the same thing, just copying the same thing here. Let me first do this. And then, so when I run this script, then it will execute F. So if I say here, display F, and I run, then you see it brings me 31. So it means I can now execute this function which I've stored here within this script. Now, since we want to implement bisection method, we need to recall how does bisection method work? It needs A and B, right? Such that f of A multiplied by f of B is less than 0. Just basically the mean value theorem that the roots has to lie in between. And if this is satisfied, then our C is the same as what? A plus B, then divided by 2. So I'm just putting this in a comment so that you know what you want to implement. And as I told you before, if you understand, you have first to understand the content, and then you want now the program now to make the content. So if we want to calculate the root of 5, can somebody give me the A and B that we can use?
4 and 6.
4 and
6.
For now, let us start with the values which work, because we know that root of 5 is around 2, right? So give me two values which we know that the root of 5 lies in between them.
2 and 3.
2 and 3.
So I can say now my A is 2 and my B is 3. Once you put semicolon, you can just write these things on the same line, or you can just write them one down. And then we execute this. So I can find my f of A, then multiply by f of B. First, let me just check them manually. If I multiply this, what do I get? It gives me an error, right? Why does it give me an error? Can somebody tell me why do we get an error?
Yes, if you multiply 2 by 3 is equals to 6. And
No, because it's saying that the error is here. So when you get such errors, just read the error to see what it means. But even just by looking at this, can somebody tell me why we have this error? I said we execute functions by calling the name of the function. So our name of the function is stored as root f. So if I want to use values, I have to use this root f we have been using. So that was the error. You call function, even if you know that this is f of A, but to find f of A, you call the name of the function and then A. And then if I compute this, what do you see? Now it gives you -4, right? So it means I can now go further and compute what? Compute C. And C is the same as what? It's just the midpoint, 0.5 of A plus B. And this is what we said, right? Is this what we said? We said you check two values. If the product has opposite signs, then you find the midpoint. And then you keep checking where the midpoint lie. So if I do this, then it means the next number will be 2.5. And then you keep checking this. But so here I've been doing manually, meaning we need the base statement. But what we want is, we want to do this process, continue doing this process until we find the root. And so to do this, we use something we call the loop. So when you do a loop, what we are basically doing is implement the same procedure, but repeatedly, just changing the input values. Right? And so when I want to get a loop in MATLAB, Susan also will also show you a loop in Python. So I say for I is equal to 1, for example, up to 10. Or let me just define here max the iteration, the number of iterations I want to do, which will also be doing in an exam. You want to compute up to 5 iterations. So if I say here, for example, 10, then I put here max it. So it means you want to change I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4, and so on until you get 10. And anytime you have a 4, you must end. I don't even, is Nando in the meeting?
Lecture,
And so,
I mean.
okay. So what I've been defining here, they are called the base statements. The base case means is like the root of your problem. So you want just this for loop, you repeat executing this base case every time. And so once we have this A and B, now we want to check, is A and B positive or is A and B negative? And so to check something is now the Boolean. We have these conditional statements using if. And so I can tell this that if this product I have here now, if this product is negative, right? Because bisection method works only if this is negative. Then you calculate the value of C. I can put here C. Else, what do you do? First of all, if the product is negative, maybe I could not have put this. And then let me put this first. First, then else, display wrong choice. Wrong choice of A and B. And then I can say here, break, right? And then end. What am I doing here? First of all, we want to check if A and B have opposite signs. Meaning, if they have the same sign, then bisection cannot do. So you can tell the program to tell you that you chose the wrong values. Can you change? So I can first of all remove this, and then you will see what we get. I've gotten this is 2.5, just the same as the other one. Now, can somebody give me two guesses that have the same sign? Like somebody made a guess before. Somebody give me two guesses where you know that if I put here X, I get either both negative or both positive.
1 and 2.
1 and 2, right? So A is 1 and B is 2. You see, when I compute, what does it tell you? It has told you here, wrong choice of A and B. It's because of this. You are telling the program that proceed only if this condition is satisfied, which is the condition for the bisection method. So this is just housekeeping, even if you don't. Nando, we spoke about with this, so Nando knows. He can explain to you later why we keep them. It's just make sure that you are not using anything wrong in the memory, so it clears the memory and clears the space.
Mm.
So now we can go back to our values, 2, and even I can even put here 4. We don't care. But so the point is, you want to repeat this process over and over again, right? So you get C, and if you have C, how does this method work? That once you get C, then you find f of A multiplied by f of C, right? And if this is negative, it means C replaces B. That's how this method works. Otherwise, it means if they have the same sign, then C and A are on the same side of the root. So the root lies between C and B. So that's what I want to do. First of all, that's just if A, this you get C. If not, you break. This is the first statement. Let me put here that this one checks if f of A and f of B have opposite signs. And then I want to put another if again. So this if is assign C to A or to B. So basically this part, we want to check if which one is negative. And so now you can say that if now I am now computing this same, I'm just copying, that if f of A and f of C have the same opposite signs, then B is equal to C. Else A is equal to C. So basically these else statements, they tell you that if one of them is not satisfied, then you follow the other one. So here, that's now the purpose of knowing the content first, because bisection method, how it works, you find A and B, you check if they have opposite signs, you find C. And then you check if A and C have opposite signs, then the root lies between A and C. Otherwise, if at C and B they have opposite signs, then the root lies between C and B. So that's what I'm doing here. That means you are starting from a larger interval, for example, here, A, B. Then depending on what happens, you reduce this interval into A, C. And then you keep on reducing this interval. So if I run this 10 times, what do I get? 2.2363. And that becomes the root of what? That's the root of 5 to some decimal places. I can put here format long G just to display so many numbers. And then maybe let me just compress this. And then I can now say here, just outside here, the display C. And so the root is 2.23632816. But I'm only doing 10 iterations. If I do, for example, 20, are there changes? Is 2.23 23606681. You see, if I put here 100, I am doing this process 100 times, but just in no time, it gets the answer. Anybody with a calculator, can you press root 5 and check if this is the answer? Calculator, MATLAB, whichever, can you press root 5?
Yes, so the answer.
This is the answer.
Huh?
It is.
2.23
2.23?
6067
67
977.
97. So you see, it's the answer we have here.
Yeah.
Yeah, so, and you see MATLAB has done it within 1 second. But it's faster, but requires the user input. So requires you to know the knowledge. So this part has been bisection method. I've not complicated this code. I just wanted you to make it simple so that you see what happens.
Dr. Maybe just a
I'll tell
question.
you later on.
How can we maybe have all the iterations maybe in tabular form? Like
That's
the way
the
we're
point.
doing class. Yeah.
That's the point I was going to make.
Okay.
That I didn't want to make this complex. One, since it is an assignment to these people.
Okay.
But later on, we can discuss with you this. But for them, we can discuss with them after the assignment. But I wanted to explain that what I'm doing here, if you start this 4, and then you don't have the indexing here, then this eliminates the previous values. So what you can put is you index this value, I. If I do I and I index it, I know it gives me the root, because this has to be C of I, and this has to be C of I, right? Instead of displaying, see, these are so many, let me just put only to even 5 so that we can see the 5. Still, we have a problem. Oh, okay. So this has to be C of I. I think that's the only error. You see now you see the values displayed.
Yeah, I see.
So it starts from 3, 2.5, 2.25, 2.15, 2.185.
Yeah.
I've just made it roughly, but I can still create a table for this. You create a table for C, you create a table for the errors, you create a table for the interval, how they decrease.
Okay.
But so this is part of this, what these people they have to investigate.
Okay.
So I've just given them the best route that calculates. Something else, you see, this I'm just going to even 1,000, but you may want to stop once your tolerance has been met. For example, you want answer to 5 decimal places. It means the difference between two successive values. If they are similar to 5 decimal places, then you stop. Those are some of the things I will want the undergraduate to go and implement, to try. Just try your best. We will not victimize you, first of all. We want you to learn, and we will guide you. But so try to investigate, try to find the stopping criterion, which means that if x, let me use underscore, x plus 1, and then minus x underscore n, it's supposed to be absolute. So if this is absolute, then it's less than what? Maybe less than, for example, 1 e to power minus 5. That just means 1 multiplied by 10 to power negative 5. So you put this. If this is met, then the program stops. You don't have to do 10,000 iterations. Until this point, do they have a question? So if they don't have, let me first of all remove this. But they are happy to even copy what I'm writing here and then go and edit it. And anybody who is using even Python, I have similar codes also in Python. You can just feel free to change these syntaxes into Python syntaxes or C++, and then you get the same behavior. Maybe I don't know if time will allow, but so at least they will have knowledge. So next we want to implement what? Newton Raphson method. So I've skipped the fixed point method. I know why. Because first of all, that one I require you to give me the g of x, where you have to solve x is equal to g of x, and then you now implement. But for now, Newton-Raphson is direct. So what does Newton-Raphson look like? Because first of all, I said you need to understand the method, right? Can somebody remind me the formula for Newton-Raphson method?
The best is just choose one person.
I don't see the skin in the background, so you can choose one of them randomly.
Okay. Anthony Katemba.
And tell us the formula, even if you want to read in your book. Go ahead.
Hello.
Yeah.
Xn plus 1 is equal to
Xn plus 1 is equal to
Xn minus f of Xn over f prime of Xn.
f of Xn divided by
f prime of Xn
over Xn. So MATLAB can do derivatives. So you guys can go and experiment with that one, right? To see how you can directly compute the derivative in MATLAB. For now, I'm just going to assume that we know the derivatives. What's the derivative of this function?
2x.
Is 2x, correct? So I'm just going to put here that f prime is equal to 2x, so that we are just using it directly. But if you want, you can also create another function of the derivative, so that if you have a complicated function, it can compute derivatives directly. And so you remember this one is for n is equal to 0, 1, 2, 3, and so on. But MATLAB starts indexing from 1. So with MATLAB, you start from 1, 2, 3. With Python, you start from 0, 1, 2, 3. It can index from 0. And so I want to go directly to making a loop, because now we have seen that we can make a loop instead of making the best case. And so for a loop, I can just use the same maximum iteration of this. So max st. So I can say max. No. So we have for I, let me just use I, just different from the other one, is equal to 1 up to max it. These i's here are just what we call the dummy variables. They can take anything you want. So choose anything you want, if I or k, jj. They are dummy variables. And what does this method do? It tells you that if I is this value, how can I start this? Can somebody choose an initial condition for this method? Choose for me initial condition.
5.
So we start with, for example, 5, right? And I'm trying to avoid using what Nando wanted, the table, where these people have to do. So I'm trying to implement something.
Okay.
So we want to find the root x, right, is equal to this xn, which is our initial value, x naught, right, minus f of xn. Remember f, we are using the same f. And to call f, I can call it using the same function here. So I can call this f into x underscore 0, right? And then divided by 2 multiplied by x 0. Why am I putting that 2 divided by x 0? 2 multiplied by x 0.
F prime of xn.
Yeah, so I'm dividing f divided by f prime. And then, so since I'm not using the indexing, anytime you compute, you have to pre-assign. You now have to tell MATLAB that the new value here you have gotten replaces the initial value. So I can now say here, x naught is the same as x. So such that you are now getting the new value. So I can now say display here values as what? Here I display x. That will be my root. Here I display c. Now can you run and see? You see the two methods. Which one is faster? If you just by guesswork, which one is faster?
Newton-Raphson.
Yeah, Newton-Raphson is, in fact, imagine we have started far away, but still we are getting more closer to the root than this one is still at 2.1. But I've told you, I've just made this roughly without using the loop. If you want to use the loop, you have to predefine x's, and then you say that xi is equal to xi minus 1. This is just implement this the way it is written. But you guys, even as you make your programs, you are free to still ask us. If you just come and ask me, I can give you hint on your program. Now at least I've made for you the program on how to start. You have the base. So upon this is just to go and modify these programs and try to make it now so that it saves the table, it saves the column for the errors, and then you can also condition it that if the error is satisfied, you stop. Does this make sense? In fact, in all these methods, the fixed point method converges faster than them, provided you get correct g of x. And the fixed point method is what is implemented in these methods when you find the root. Is what is implemented to find the square root of numbers, even in your calculators. So because of time, I don't want to go beyond the time because today is a weekend. But because of time, you guys can do the same thing just using to get the fixed point method. Let me just get for you the hint. So this is fixed point method, right? Can somebody remind us? Nanda, pick one person randomly first before we go. Nando alihepa meeting. Alan, tell us the formula for fixed point method.
Oh, sorry, I was muted. I had chosen Lucy Mbide.
Lucy, okay, Lucy.
Or Lucy Nyambura.
Lucy Nyambura, Lucy Ndida, one of you. Wasichana sijui nakupanga nini.
Or Sheila Mumbi.
So because of time, it's just similar to Newton-Raphson method, right? X at n plus 1 is the same as g at xn. So you have to define your correct g from this and then use the g. And then so you see, this is the easiest one to implement. You just now have for I is equal to 1 up to max it and then you end. And then you have what? X is the same as G of X naught, where you start from. And then you do the same thing I've said here. X naught is the same as X. I'm doing this because I'm not using the indexing, saving the table. If you do the table, this line is not important because it will update from in the table. If you do the table, this line is not important. So this one, I cannot run it because I don't have my GX. So let me just comment on it. So if somebody who wants to try this, if you get the correct G, then just go and replace here the G. Define it the same way. You define root F, define root G, or just my G, or you can call it fixed G because for fixed point method. And then just come back and put here the G, and then you get this one by fixed point method. And you recall what we said, we're finding the roots. How do you find the G? You just have 2x squared. I think this is the same as x squared minus 5. I've just added x squared on both sides, such that if I do this, then my G of x is equal to what? Is the same as x squared minus 5, then divided by 2x. I think this would be, yeah, my G of x. Then you can try to use it. Let me see if we can implement this faster without having to store this function. So I can replace this here by this person, and then I put here, so let me hope I'm doing the correct thing. And then I put here 0. So if I have to put here a product, then I put the bracket. And then I put here comment. So I'm still calling also, yeah, but I'm displaying them at different points. Let me see. Huh? Oh, so also this fixed point, if you start far away, it converges so slowly. You see, still it's still not converged, right? But if I make this, for example, even 100, then you can see these methods. I think maybe there's something we did wrong with.
G.
Go and confirm our G of x seems not correct, right? Yeah, our G of x seems not. Okay. So this was supposed to divide everything. But I divide everything by this. But still, that one goes to 0. So I think there is something wrong somewhere that we need to go and confirm. Just get the correct G, and then you replace what we have at this point. Is that okay?
Like, where's the 2x squared coming from?
Which one? Because you have x squared is equal to 5. So I added x squared on both sides.
Okay.
Yeah, that's what I did. You remember this, you have this x. It's supposed to be a plus or a minus because we have x squared is equal to 5. So these are plus. A plus, and then I have a plus here. You see now it gets the correct thing.
Yeah.
Let me now try to 5 iterations to see which ones maybe is more accurate. You see these two are similar to even 5 iterations.
Yeah.
Okay. So you can go and implement this. So somebody who asked that question, do you know where it came from?
Yes.
Yeah, I just added x squared on both sides. Remember, I told you in class that getting G of x is important. and the derivative has to be less than 1 near the root. Otherwise, convergence is not guaranteed. So at least we have learned 3 methods. I've just give you the basic case of which can give you the method. What you only need is to make sure that you save the table, as Nando had asked, and also try to include a part in your program if you can, such that even if you have a million iterations, it can stop even on the second iteration, provided it has gotten the correct root. And at this point, I'm ready to stop unless somebody has a question.
Maybe just a comment, Dr.
Yeah.
Yeah, so thank you for the lesson. So to the students, I would like to advise you that it's good to actually perfect your skills in both theory and programming. Don't replace one for the other. You have to go with both of them. Because as you see from the explanation by Dr. Victor, if you don't understand the theory, then it becomes a problem to do the coding. So you have to understand the method first before you are able now to do the coding. So the two skills go hand in hand. So don't, when we have the two types of session, the programming class and theoretical class, some students can prefer to be perfect in one and then forego the other. Say you say that I'll be attending the classes and coding alone because that was what I was told that is more practical. I avoid classes. Or I do go to class because exam will be theoretical and I avoid programming. That will not be helping you. So make efforts to be an active participant in both sessions so that when you go to classes, the Mondays classes, you get your theory well, so that when it comes to the programming aspect, then you are okay. Because at the end of the day, you are a little bit more lucky than some of us when you are at your level, because those who are teaching us who are not giving the skills on programming. So some of the things we are learning when we are old. So for you, you are luckier, so try to make use of this opportunity to perfecting your skills. And as I usually tell you, that you have to be better than us so that we learn more from each other. So as you perfect your skills, ensure that you get the math right. I remember Dr. Ongaro used to tell us that if you don't know the mathematics, then you can't do the programming. So you really have to understand the concepts first, then do the programming. All of them are actually congenital traits. If you are so good in theory, you are not good in programming, you will not go far. And the reverse is also true. So ensure that you get the skills in both areas so that you become a very serious mathematics student. So thank you, and maybe back to Dr.
No, you can tell them one thing, that at this level, both skills are needed.
Yeah.
In future, when you grow up, and then you can start to specialize in one. Just become purely programming. You can go to these big data companies, and then you work as a programmer in those companies, which, by the way, they give you a lot of money. Or you can go the theoretical way. You help people develop concepts, and then they can implement. So for now, you have both skills. In the future, you can decide which one is better.
It's true. Good.